So let's talk about comparing and ordering decimals. Remember, a decimal is just a fraction. That's all it is. So when you're comparing, you have to find something they both have, apples to apples. So let's look at this first set. This one's pretty easy to compare. 31 hundredths, so if you think of it as a fraction, it looks like this, 41 hundredths. So which is more, 31 out of 100 or 41 out of 100? Well, that's pretty easy to know that 41 out of 100 is more. But now let's look at this one. This means 9 hundredths, meaning 9 out of 100, right? So 9 pennies, basically. This means 1/10. Well, if you think of a dollar cut into 10, that would be a dime each, right? Well, these both are not the same thing, so we can't compare them that way. Well, a 10 can become 100 easily by timesing 10, which would be 10 over 100. So which is more, 9 out of 100 or 10 out of 100? 10 out of 100 would be more. Or you can look at it as there's 2 digits behind the decimal here, so you have to have 2 digits behind the decimal here. Well, the only digit we can add that doesn't add value is a 0. So again, 10 hundredths is more than 9 hundredths. Let's look at this one right here. This one's a little different because you should automatically see the holes. So right away, you know that 1 whole pizza and extra is going to be more than 0 whole pizzas and extra. So 1 whole would be more. This one, 2 wholes and 2 wholes, neither of those are bigger. Then you've got 70 out of 100 or 7 out of 10. Well, you can't compare those. They have to be the same thing. So this one, we would have to times it by 10 to give us 100. And then 7 times 10 would be 70. So which is more, 2 and 70 out of 100 or 2 and 70 out of 100? Well, neither are more. So this one would be equal. Again, if you had this same one, you could look at it just as a decimal, but you have to compare apples to apples. So this has 2 digits behind the decimal. This one has to have 2 digits behind the decimal. So again, they still would be equal. Let's look at these down here. We're going to compare these. All of them have 2 digits behind the decimal, so we're comparing apples to apples. We're going to go from smallest to greatest. Think of it as a fraction. Is 26 out of 100, 13 out of 100, 1 whole and 56 out of 100, or 78 out of 100 the smallest? Which one would be the smallest? Well, 13 out of 100 would be the smallest, so that would be our first one. Okay, then the second one, 26 out of 100, 1 and 56 out of 100, or 78 out of 100. Well, 26 out of 100 would be next. Okay, now these two, this one might trick you to think that it's smaller, but it has a 1 whole. So if you have a whole pizza and some extra, isn't that more than just some extra? So this one would be the next one. Then your one that's 1 whole is actually your most amount, your biggest amount there. Okay, let's look at this one. Make sure we're comparing apples to apples. We have 2 digits behind the decimal, 2 digits behind the decimal, 1 digit behind the decimal, 2 digits behind the decimal. So this one we need to make to have 2 digits. The only thing we can put back there that doesn't change the value is a 0. Because remember, if you have 5 and 9 tenths, meaning 9 dimes, that's the same as 5 and 90 hundredths, which would be 90 pennies. They both mean 90 cents. Okay, so now let's look at it. Which one's the smallest? 5 and 63 out of 100, 5 and 33 out of 100, 5 and 90 out of 100, or 5 and 2 out of 100? Well, 5 and 2 out of 100 would be the smallest, 5 and 2 hundredths. Okay, followed by 5 and 33 hundredths. Okay, then followed by 5 and 63 out of 100. And then this one would be 5 and 90 out of 100, but we need to write it in its original form. So 5 and 9 tenths, meaning 90 cents, 9 dimes. That's still more than 5 and 2 pennies, 5 and 33, 5 and 63. This would still be more.